Good morning. The modest research I will be presenting at your seminar is titled Application of a Series of Heterocyclic Compounds as Catalysts for the Oxidation of Catechol. Biomimetic chemistry is a scientific investigation method that involves mimicking the laws of nature to create new synthetic compounds. Biomimetic chemistry is another aspect in which biological information intersects with chemistry. In spirit, new chemistry based on principles employed by nature. Biomimetic chemistry has evolved to mimic bioorganic process in natural enzymes and understand their mechanisms of action. Developing biomimetic catalysts requires a deep understanding of biological systems. The goal of our work is to research and discover new catalysts for known organic reactions. The synthesis of our two compounds is summarized by the following reaction. So, to a hot ethanolic solution of hydroacetic acid was added 4-fluoroaniline for L1, 4-chloroaniline for L2, and 4-bromoaniline for L3. This table provides us with the analytical characteristics of the synthesized compounds. All the compounds are obtained in solid form with good yield. The brown color that typically develops when a potato, an apple, or a banana is cut is the result of a chemical catalyzed by several enzymes. The catechol is one of the most important of these enzymes. This enzyme comes into contact with the substrate, which is the catechol, when plant tissues are damaged and exposed to air, oxygen. Catechol is released and the enzyme converts it into orthoquinone, which is a brownish color product. It plays a role in plant defense mechanism, helping to protect damaged plants against bacterial disease. The study is based on a model reaction, catechol oxidation. This method relies on the in situ formation of complexes by mixing the lesion with the metal salts, followed by the addition of solution of the same concentration of catechol at room temperature. Catecholase is the oxidation of the catechol to orthoquinone. This chemical transformation is catalyzed by an active enzyme called catechol oxidase. It's the process of catecholase activity that involves the reduction of 4 electrons from molecular oxygen into water molecules, as illustrated in the chart. The experiments were conducted at room temperature in methanol using a UV visible spectrometer, and the metal salts used are indicated with the catechol substrate. The first figure shows that the oxidation of catechol alone it can be observed that there is no catalytic reaction taking place. The second figure represents the oxidation of catechol in the presence of copper metal salts. A weak result is observed with copper acetate. The oxidation of catechol in the presence of the copper complexes formed shows that the best result is obtained with compound L1 with almost all copper salts. The catalytic study as a function of concentration has shown that the catalytic efficiency of the complexes improves with the increase in the quantity of the metallic salt relative to the ligand. The oxidation rate has reached its maximum value with the ratio 1 to 2 ligand metallic salt. As a conclusion, we can say that all the compounds exhibited good catalytic activity. The best result was obtained with compound L1 at 1 equivalent of the ligand and 2 equivalents of copper acetate. So, catalytic activity is influenced by the three parameters. First, the nature of the ligands. Second, the nature of the anion that bind to the metal. And finally, the concentration of the substrate. Thank you for listening.